All right, let's do a similar problem. If this reaction goes to completion, let's figure out how much ammonia gas we can produce. Okay, that's good. What was the answer to the question?
I forget what the question was, but...
Here's the question.
So it takes, well, H2 is the limiting reagent, and it produces 8 moles of NH3.
Good, that's right, good. Okay, now let's go through the steps of that. So let's review what the technique is for finding the limiting reagent, because I think you got off on the wrong foot, finding the limiting reagent there. The basic technique is we're going to ask how much ammonia can we produce from the nitrogen, and we'll compare that to how much ammonia we can produce from the hydrogen, and that will tell us which the limiting reagent was. It seemed to me like you were trying to convert from nitrogen to hydrogen, but what we want to do is convert the starting materials into the product. So we have here starting information of 5 moles of nitrogen. And if I want to find the limiting reagent, what should be my target unit?
NH3.
Yeah, moles of NH3. And then this conversion would be moles of N2 over moles of NH3. So based on the stoichiometric coefficients, this would be 2 over 1. So am I getting this right? It looks like we have enough nitrogen to make 10 moles of ammonia. Is that what you got? All right, and now what's the next conversion I should do? What should be my starting information now?
The H2.
Yeah, what number?
12.
Yeah, 12 moles of H2. We don't say 3. This is not the starting information. We're going to use that for our conversion ratio. What's our target unit?
NH3.
Right. In both cases, we want to figure out how much product we can make. We're not trying to convert between the 2 starting materials. So then we would have moles of H2, moles of NH3. Now I use the stoichiometric coefficients. 3 goes into 12 4 times. So that gives 8, which was the correct answer. That actually just gives us the answer right there. Yeah. Wow. So if this was the real test, you would stop with that. But it's good that you went on and figured out some other things to get some more insight. Since this is the limiting reagent, what's going to be the change in the hydrogen?
Minus everything?
Yeah.
Minus
This is what we're going to run out of, so we had to run out of it. So we're going to use up all of it. And then you went on now to figure out how much nitrogen we were going to use. Now is the time when maybe you might want to convert between these two things, but not at the beginning. So here we have 12 moles of hydrogen, and that's being converted into moles of nitrogen. And we have 1 mole nitrogen for every 3 moles hydrogen. Did you get 4 for that? Okay.
Yeah.
That's not our end, that's our change, which you correctly saw. So we end up with 1 mole here and 0 moles here. Again, this is just the icing on the cake. We could have stopped here based on what the question was asking us for. Okay, and this again shows that this is the excess reagent and this is the limiting reagent, and you did what I recommended and cross this out. So we're not going to get confused with it. We're not actually going to be able to make all 10 moles, as it turned out. We're only going to make the 8 moles. Now, the method I'm showing you here is not the only way to find limiting reagents. It is possible to find the limiting reagent doing what you were trying to do. It is possible to find the limiting reagent by comparing the amounts of starting materials. But
It gave me an erroneous number.
If you do it right,
that's
you
why I
can get it
knew
right. Yeah.
that I didn't have the limiting reagent.
Yeah.
Because it came up with something like -2 hydrogen or something.
Right. Yeah. So there is a way to use your method to get the right answer. And it's not that complicated if you look at that. But why don't we just learn one method? And I think this is the best method. So I think this is the best method for finding limiting reagent. The best method is to ask how much product you could get out of each starting material. One reason why that's best is because then once you're done, you've already answered the question. The question was just asking us for the 8 moles. Whereas if we just focus on the starting materials, even after we found the limiting reagent, we'll still have another step where we have to figure out the amount of product. So in most cases, the best way to find the limiting reagent is to convert each starting material into product and see what you can get more of, even though admittedly there are other ways that could work. But this is good enough, so we might as well stick with this. Okay. And notice that once we found the limiting reagent, this number was obvious. But this number wasn't obvious. We had to do more work to figure out this number down here. A lot of people forget about all this and they get sloppy and they just, well, here's some mistakes that some people make. So some people would say, oh, this is -12, so this should be -12. Well, that's pretty obviously doesn't make sense in this case. But you can't assume the changes are always the same. Doesn't make sense because we're using up some of these faster than other things. Just like when you're making a sandwich, you're not going to use as many slices of bread as slices of salami. So we can't assume that all the changes will be the same. Another mistake people make, if they haven't looked at this material for a while, is that when they're starting a problem fresh, if they set up the start change end table, they just automatically write down this. They just copy the number from one row to the next row. Well, it doesn't work that way. We're not necessarily going to use up all of both of these. We're only going to use up all of the limiting reagent. But if you haven't thought about this for a while, it's easy to make those mistakes if you're just trying to kind of doing the problems mechanically. So again, the key thing is, when you're dealing with a chemical reaction, what are the steps? First step, balance the equation. Dealing with a chemical reaction, well, first step, write the equation. If you aren't given it, first step, write the equation, and then, if necessary, balance it. Very helpful to write down the chemical reaction that's happening, and then try to balance it.
Right.
And then you have to ask yourself, is this an equilibrium reaction or one that's going to completion? Because they're solved in 2 different ways. And there should be some clue in the problem that will tell you whether it's equilibrium or going to completion. All right, and we're focusing on what to do then if it's going to completion. If it's going to completion, you must now find the limiting reagent. You can't fill out any more numbers until you know the limiting reagent. The mistake that people make here is they just start plunging straight ahead and just copying numbers from one row to the other, but they haven't found the limiting reagent, so they don't know which of those numbers is right and which is wrong. If the reaction goes to completion, we must find the limiting reagent, and we've gone over a technique for doing that. All right, and once you've found the limiting reagent, you should go out now to fill out the table and continue working. Okay. All right, so far I've been simplifying these problems. What have I been leaving out? I've been putting everything in moles, but on the test things will be in grams. So now we have to see how to work with this in grams. Well, it's the same basic approach. You still have to find the limiting reagent, but you won't be able to figure out the limiting reagent while things are in grams, because that doesn't match up with our stoichiometric coefficients. So you're going to have to put things into moles to work that out. So let's try an example. Oh, going back to this for a second, what was the lesson that I wanted to teach with this problem? Minus 12, minus 4, 1, 0, plus 8. Here's another mistake people could make here. A lot of people try to find the limiting reagent in their head. And if they do that, they would say, well, the limiting reagent is what I'm going to run out of first. I've got way less nitrogen than hydrogen, so I'm going to run out of nitrogen first. And then they would go in and say that this was a minus 5, say. Well, the problem with that is it's true that this being a small number would tend to make this limiting reagent, but the other factor is what we're using faster. And we're using the hydrogen 3 times as fast as the nitrogen. So in many cases, it's dangerous to try to find the limiting reagent in your head. Instead, try to work it out mathematically, like we did down here. Okay. So now let's think about these problems in grams.